Hi everybody, I'm Maxim Lukianov, Program Manager on Azure HDInsight team. In this video, I'm excited to announce new development tools for Spark. They allow remote breakpoint debugging of Spark jobs on Azure HDInsight service. The new tools bring ability to debug not only driver code, but executor code as well. This, for the first time in industry, brings full distributed debugging to the world of Spark. In the past, we had to rely on a so-called log debugging to debug scalable jobs, scalable Spark jobs. And that required us to collect these logs from all of the executors, then scan through them and find error messages, and then try to deduce what these error messages mean and what data resulted in these errors. Then maybe we would need to add additional logging into our job and run it again, and do it in cycles. So that was fairly unproductive. With new tools, now we can attach debugger directly to the Spark job running in staging environment or even in production. This changes our development process, and in the new debugging cycle, we can now stop Spark job directly in the moment when the error occurs. We can use local variable tools to inspect what data caused the error. Then we can fix the error, and even more impressive, we can reload classes without stopping the job and resume the execution of the job. This cuts out whole sections of whole iterations from our debugging process and improves productivity. To illustrate these new tools, let's take a look at the demo. In this demo, we'll simulate fairly common situation with production Spark jobs. In this case, our job was programmed to expect date values in the Unix epoch file format, in the Unix epoch format. But something happened to our data, and now we have new entries in the ISO format, which breaks our job. So let's see how we will use new debugging tools to investigate this problem. New HDInsight development tools are available as part of the Azure Toolkit for IntelliJ IDEA, which is a Scala development environment. So here we have our Spark job that does fairly traditional kind of set of steps. First, it reads the data from some CSV file. Then it performs some transformation in this map function. Then converts it into a data frame for further analysis and saves the results in some other output file. So here, as a first step, let's run this job and see what kind of error it produces. The part of the functionality of HDInsight Toolkit for IntelliJ is ability to seamlessly submit your Spark job to HDInsight cluster. So here we can connect IntelliJ to our Azure account, Azure subscription, select this Spark cluster that we want to submit our program to, and just click Submit. The toolkit in IntelliJ will compile the Spark program and submit it remotely to our HDInsight cluster. As expected, our job failed, and we can see here that the error message is fairly generic. So now let's investigate why our job on a new dataset started to fail. To do this, we will use our new debugging capabilities of HDInsight Toolkit for IntelliJ. So first, we'll configure our configuration of the remote cluster. So it's similar to the previous dialog where we submitted the job, but now we have advanced configuration where we can enable IntelliJ to connect to our Spark cluster using SSH tunnel. So after specifying the SSH credentials, which I have already done here, IntelliJ Toolkit can connect to any executor and driver node on the cluster. So this enables new debugging capabilities. So let's first set a breakpoint in our job inside of this data transformation phase of the program to see what kind of normal data our job process. And then we can click on the debug button here to launch remote debugging session. Again, IntelliJ would detect if any changes happen to our program, compile it, upload it to a blob storage so our cluster has access to our new new code and launch the distributed Spark job on the cluster. The first phase of the process is attaching debugger of IntelliJ to our driver and executor code. You can see how IntelliJ plugin automatically detects all of the executors of our Spark program and attaches debugger to it. The HDInsight plugin fully leverages built-in capabilities of IntelliJ for debugging. So all of the capabilities of the debugger are available to us. For example, our breakpoint already hit, and we can inspect what kind of data our program processes in the normal run. In this case, our executor on the node 1016 hit the breakpoint. So that's one of the distributed elements of our program that stopped execution according to our breakpoint. So we can see that the attributes field that is processed here in this snippet of code is representing kind of expected Unix time in a Unix epoch format. So now let's see how we can stop our program at the moment when it actually fails. In Spark, there is a great helper to do just that, that allows us to add a listener to our Spark context, task context, that will be triggered exactly at the moment whenever any exception happens inside of our executor code, inside of our map function. So let's put a breakpoint directly here, remove the original breakpoint, and resume execution. One of the more tricky aspects of the distributed debugging is that we are dealing with multiple executors at the same time. And one thing that is good to keep in mind, whenever we click resume, we need to double check that we have resumed all of the executors, because multiple of the executors can actually stop execution. And that may lead to situations where we are waiting for the program and program is waiting for us. So for example, this executor actually also hit the breakpoint, so we need to resume that executor as well. That's a very good kind of a practice to check all of the executors when you're performing distributed debugging. So now our breakpoint that is assigned to the failure listener also hit, and we can expect what data actually caused our program to fail. So here we can immediately see that the exception that caused our program to stop was number format exception. And as expected from our demo, the input string now is in the ISO format. But the highlight here is that we didn't need to kind of extract this data from the data set or from logs. We can immediately stop our program automatically at the failure point and inspect what data caused this program to caused our program to fail. So now that we know what kind of data failed our program, we can directly go and, without stopping the debugging session, we can change our program to accommodate for the new data. So let's say we'll add a catch clause to our data processing code that would also accommodate the ISO data format. So now that we have fixed that, we can use IntelliJ capability to recompile the code live and update all of the executors with a new code. So after the classes are reloaded, we can resume execution of our program. So we'll click resume and see if this time it's able to complete. So now looks like the program has completed. Let's examine what happened. So if you go back to our driver logs, and scroll up, we can see how our program finished the execution. So, and we can see that it actually succeeded. So it was able to successfully complete the job, even though originally it hit the exception. So how did that happen? So if you scroll up, then we can see that our original number format exception actually did break one of the task executions. But a nice feature of Spark that actually goes hand in hand with the new debugging capabilities is that once we fixed the code and relaunched our executor, then Spark was able to relaunch this task, to repeat the failed task execution. So we can see it as a task 1.1 that was repeated, and then after the code was fixed, it actually finished successfully. So that allows us to basically, without stopping or restarting our job, to fix it at the moment when the failures happen and just resume execution. Again, this reduces the number of iterations that we need to spend debugging our code and significantly improves our productivity. In this video, we learned how we can use new debugging tools to debug our distributed Spark jobs on Azure HDInsight. If you'd like to learn more, I can recommend you reading our documentation that describes HDInsight tools for IntelliJ, or jumping directly into articles that provides you a step-by-step guide of how you can do remote debugging of Spark jobs using IntelliJ. Thank you for watching this video and have a great day.